Hey there and happy Monday. We're looking at 3.2 today on solving quadratic equations by graphing. So if you remember from Friday, we looked at 3.1 on just graphing quadratics. And a couple of the key things we looked at is being able to find the axis of symmetry, the vertex, and the points of the x and y intercepts. And so we're going to use that today because to solve a quadratic, if you go back to chapter 2, remember when we talked about roots and zeros and x-intercepts and solutions, those all relate. And that's the first thing we're going to look at here in a second. And so our objective today is to solve quadratic functions by graphing and to estimate their solutions by graphing. And so remember that our FIF 7 standard, remember it says to graph simple cases by hand and use technology for complicated cases. Well, complicated cases would include those that have irrational roots. And we'll look at a couple of cases of those today. So remember from chapter 2 that roots and zeros both relate to the x-intercepts of the graph. Remember that roots deal with an equation and zeros deal with a function. So let's look at the first example here. Solve x squared plus 6x plus 8 is equal to 0. And so remember, we're going to first find the axis of symmetry. And that axis of symmetry, remember the formula is x equals the opposite of b over 2a. And so remember, our b is in front of the x term, our a is in front of the x squared term, and so our b is 6, so we're going to get the opposite of 6 over 2 times 1, so it's negative 6 over 2, which is negative 3. And so my axis of symmetry is x equals negative 3. And so that's coming down like so. We can then find our vertex. Remember, our vertex is by taking this negative 3 and plugging it in for x. And so we're going to get negative 3 squared plus 6 times the negative 3 plus the 8. That's equal to our y. And so negative 3 squared is 9. 6 and negative 3 is going to give us a negative 18 plus the 8. And so we get negative 9 plus 8 is negative 1. And that's equal to our y. And so my vertex is at negative 3, negative 1. Now, go back to chapter 2 again, think about opening direction, right? Our A is positive, which means this graph is going to open up like so. And so the question is, where is this going to cross the x-axis? And so we could use a table of values, and again, when we're graphing, that's one thing we could do. And so I'm going to plug in an x value here of negative 2, because that's the next one over from negative 3. And so we're plugging that into x squared plus 6x plus 8. And so we get negative 2 squared plus 6 times the negative 2 plus the 8. Negative 2 is 4. 6 times the negative 2 is negative 12. And add to the 8. All that added together gives us 0. And so I end up with a point at negative 2, 0. And remember what we talked about in section 1. We said that if something was so far away on one side, it would also be equidistant, the same distance away on the other side. And so this is 1 unit to the right, so I'm going to end up with 1 unit to the left. And so go back to our note, right? Roots and zeros both relate to the what? X-intercepts. And so my two solutions is when x equals negative 4 or x equals negative 2. And we could show that as a set in braces, negative 4, negative 2. And you might also see it with the x such that x is equal to negative 4 or negative 2. Again, just depends on the context and how formal they're writing the solutions. And so we could finish this graph off, but it doesn't matter, right? We're just looking to solve by graphing. And so our graph would, again, it would trend upward, and it's a parabola, so it's not going to be a straight line. But it would look something like that. We could find more values if we needed to. But again, the key is we're looking for the solutions, and the solutions are where they cross the x-axis, those x-intercepts that we have. And so let's look at this graph here. And so I want you to try this one on your own. Again, use what we did in the previous problem. Find that axis of symmetry, find the vertex, and plot some points in the table. So go ahead and pause the video for a second and try out this graph. All right, did you pause it? I hope you did, because here we go. So the axis of symmetry, AOS, right? Axis of symmetry is equal to x equals the opposite of b over 2a. And so our b is 2, and our a is 1. So we're going to get the opposite of 2 over 2 times 1. And so it's negative 2 over 2, which is negative 1. And so my axis of symmetry is at negative 1 on this graph. And so remember, we're going to take that x-coordinate and plug it back in to get the y. And so we're going to get negative 1 plus 2 times negative 1 minus the 3. That's equal to our y value, negative 1 squared. And so negative 1 squared is positive 1. 2 minus 1 is negative 2. Minus the 3, that gives us our y value. So this is going to be negative 4 is equal to y. And so our dot is there. And so again, we get to set up our table of x's and y's, and we're plugging into x squared plus 2x minus 3 to find out our y value. And so I can go to 0 and figure out what the y-intercept is, but remember, 0 is just when all the x's become 0, so that's negative 3. And so that point's going to be here. And remember, whatever happens on the right will reflect to the left, so this is 1 unit right, so 1 unit left will end me up here. We're going to plug in positive 1. And so we're going to get 1 squared plus 2 times the 1 minus the 3. Don't need a parenthesis there. And so 1 plus 2 minus 3. 1 plus 2 is 3. Minus 3 is 0. And so I end up at 1, 0. That is 2 units away from my axis of symmetry. So that's going to reflect 2 units to the other side. And this is the parabola we end up with. And remember that our solutions are where it crosses the x-axis, because those are our roots. And if we were dealing with a function, we call them zeros. And so where are my solutions? Well, it's at x equals negative 3, or x is equal to 1. And remember, we could write it into set notation like so. And so our two solutions, negative 3, positive 1 in that graph. Did you get that for this answer? If you did, give yourself a little pat on the back. And we're going to move on. And so the key to knowing solutions to a quadratic is knowing how many solutions are going to be. Well, the first two problems we looked at, what did the graph look like? Well, it looked like a graph where it had crossing the x-axis twice, and it had how many solutions? 2, because it had 1 here and 1 here, right? Wherever these 2 crossings would be. And so a graph that looks like this would have 2 solutions at each x-intercept. And it doesn't matter if the graph is opening up or opening down, it's going to cross the x-axis twice, so it has 2 solutions. But is that the only case that I have when it comes to our parabola? No. Well, we could have a parabola that never touches the x-axis, right? And so if this parabola never touches the x-axis, how many solutions would it have? Well, the answer there would be 0 solutions, because, again, it never touches, so it doesn't have a solution, right? Because remember, x-intercepts relate to the roots, which relate to the zeros. But there is a third case, and that's the case we're going to look at next. And so, what if my graph were to come down, and I could come from the bottom, have it opening up like this, come up, touch the x-axis, and return, such that my vertex is on the x-axis? How many solutions would that have? Well, it only touches once. So it's going to have what? 1 solution. And its only solution will be at the x-axis. It's the x-intercept. Right? And so now this will get us into what we're going to do tomorrow in 3.4. Again, we're doing a flip here with a couple sections. We'll do 3.4 tomorrow and then 3.3 after that. But we'll talk more about how this is really 2 solutions that are repeated at this value when we get into later sections of this chapter. But for right now, understand this is 1 unique solution at whatever x-intercept value that is. And so let's look at this graph here. We've got x squared minus 4x is equal to negative 4, and we're going to solve this by graphing. Now, if we're going to solve this by graphing, one thing we do have to know is that it has to be set equal to 0 to solve by graphing. And so if I've got my x squared minus 4x equals negative 4, I'm going to add the 4 to both sides and get x squared minus 4x plus the 4 is equal to 0. And so to graph this, we're going to get my axis of symmetry now. And so x is equal to the opposite of b over 2a. And so the opposite of negative 4 over 2 times 1, that's going to give me 4 over 2, which is 2. And so my axis of symmetry is coming through like so. And so we're going to plug that back in to find our vertex. And so 2 squared minus 4 times 2 plus the 4. So we're going to get 4 minus 8 plus 4, that's equal to our y. And 4 and 4 is 8, minus 8 gives us 0. And so we end up with our vertex at 2, 0. And so just to see what happens to this graph, see if it opens up or down, you should already know based on the x value if it's going to open up or down. But let's just plug in a value that's next to it. So we'll go to 1. And so we're going to get 1 squared minus 4 times 1 plus the 4. And so it's 1 minus 4 plus 4. The plus 4 and the minus 4 will cancel, so that gives me 1. And so I'm at 1, 1. And then if I go to 0, remember that's just plugging in 0 for each of these x's, so we end up at 4. And so these 2 points will reflect. This point is 1 unit to the left, so we end up 1 unit to the right. This point is 2 units to the left, so we end up 2 points, 2 units to the right. And we end up with a parabola that looks like so. And so where is my solution? Well, my only solution is where it touches the x-axis, and that is at x equals 2. That is the only solution we have. Now, again, we're going to talk later this unit about repeated solutions and what that means and to our graph. But for right now, understand that this is one solution at x equals 2 when we solve in this method. And so we're going to look at this example here, using a quadratic to find two numbers with a sum of 0 and a product of -9. Well, let's talk about how we can find the two numbers that have a sum of 0. Now, the first number would be x, right? The first number is x. And the second number, if I'm trying to get to a sum of 0, would be 0 minus x, because if I take those two numbers together, right, or just negative x, but x plus 0 would equal to 0, because these two would cancel and I get left with the 0. And so the product of -9, so I'm going to take the first number, so x, and so we're going to get x times 0 minus x, so the product of those two is equal to -9. And so when we multiply this out, remember 0 minus x would just be -x. So we're going to get negative x squared is equal to -9, because x times 0 is just 0, and x times -x is -x squared. And so adding this across, so I get it set equal to 0. I'm going to get -x squared is or adding the 9 across, right? Plus 9 and plus 9. So we add the 9 across, and we get equal to 0. And so graphing this up, so let's get the axis of symmetry. So the axis of symmetry, and sorry, I'm having to write with my finger because my pen died. So axis of symmetry, x equals the opposite of b over 2a. And so the opposite of b, well, in here there's no b, because the b would be attached to the x term. And so our b is 0 over 2 times the -1. And so that's going to be equal to 0, because 0 over anything other than 0 is 0. And so my axis of symmetry is the y-axis. And so now we figure out what our y-intercept is going to be. Well, our y-intercept told us right here. Our y-intercept is positive 9. So I'm going to put my dot up here. It's going to be a little hard for me to do. But my dot will be up here at 9. Okay, and so now we need to find the rest of our graph. And so doing our table, x, we've got -x squared plus the 9. And we can plug in some x values here. We can go to 1, and so that's going to be the opposite of 1 squared plus the 9. So it's going to give me -1 plus 9, which is 8. And then so it's giving me a point there. And again, my dots are a little off because I'm doing this with my finger and not the stylus. We go to 2. Remember, the negative's out front, then the 2 squared plus the 9. So it's going to give us -4 plus 9 is 5. And when we go to 3, we get the opposite of 3 squared plus the 9. And so it's going to be -9 plus 9, which is 0. And so that gives me my point right there at 3, 0. And remember, if I'm so far away to the left, means I'm so far away to the right, which means my other point is right there. And so my parabola would look like this. And so where are my two solutions? Well, my two solutions are x equals -3 or x is equal to +3. Another way we can write that is x equals positive or -3, or we'll do it in our set like so. And so again, there are easier ways to do this than by graphing, and we're going to talk about those later in this chapter as we get through the rest of it. But for right now, we're looking just at graphing these up. All right, so let's look at a similar example. But obviously, as you can see with example 3, we're talking about problems that have no real solutions. And so we're going to use a quadratic equation to find the numbers with a sum of 4 and a product of 5. And so we're going to set it up the same way. Remember, our first number is going to be x, and then we're adding that to another number that is going to sum to 4. And so 4 minus x. Because x and negative x, when we add those together, the x and negative x cancel, and we get 4, right? And so when we multiply those two things together, we want a product of 5. And so we're going to get 4x, multiplying that, minus x squared is equal to 5. We're going to subtract the 5 across, and rearranging, we get negative x squared plus 4x minus the 5 is equal to 0. And so we can graph this function as well. And so we find our axis of symmetry. X equals the opposite of b over 2a. And so that's going to be equal to, my pen keeps dying, the opposite of b, so the opposite of 4 over 2 times -1. And so that's going to be -4 over -2, and so that is positive 2. And so my axis of symmetry is at x equals 2. So my line is coming down. Again, you'll please forgive me for my pen dying here. So x equal to 2. And again, we can plug into our table x and y. And we're going to see that our y-intercept is -5. And so starting with the 2 first, my y-intercept is down here at -5, because again, the -5 there. This is opening down. So the opposite of 2 squared plus 4 times 2 minus the 5. And so that's -4. That's a positive 8, so it gives me -4. Minus 5 gives me -1. And so my y-intercept is below the x-axis as well. Again, little difficulties here with doing this by hand. Get my pen here to work for a second. But we'll see that this, and again, I'll reflect a point across, ends up with a parabola that looks like this. Does it ever touch the x-axis? No. And so this has what? No solution. Okay. All right, so let's look at example 4. Estimating the roots. So solve negative x squared plus 4x minus 1 is equal to 0 by graphing. If the exact roots can be found, state the consecutive integers between which they're located. And so for this, I would go to a graphing tool like your graphing calculators. You could do a table here, and it's not too hard to do a table with this. Again, it'd be a little easier if I had a working pen this morning, but that's what happens when I'm recording this still from Florida, so y'all have this video today. And so our axis of symmetry, we figured that out, right? Our axis of symmetry is going to be x equals the opposite of b, so 4 over the 2 times -1. There's not a negative in front of that 2, so let me just make sure we don't have that sitting there. And so that's going to give us a positive 2 in the end. So 2 here, when we come across and we write this all out, so we're going to get the opposite of 2 squared plus 4 times 2 minus the 1. So this is -4 plus 8 minus 1. So this is 4 minus 1 is 3. So let's go to x being 3. Or we can go to the other direction and go to, we can go to 1, because that's an easier number. So the opposite of 1 squared plus 4 times 1 minus the 1. So it's going to be -1 plus 4 minus 1. That's 2. And then we go to 0. Well, 0 is just -1. And so my y's went from being positive to negative here. And so somewhere between 1 and 0 on my graph. So if we're talking on our graph here, 1, 2, 3, right? We were at 2, 3, 1, 2, 3. And then 1, 2. And then my next point was at 0, -1. So somewhere in here, it crosses the x-axis. So the consecutive integer it crosses between are between 0 and 1. So my crossing is between 0 and 1. And my other crossing, again, reflecting across, so this point's here, and this point's over here at 4. So, again, pins being a little finicky as the battery's dying. But my other crossing is between 3 and 4, and so my other crossing is between 3 and 4. Okay, and so this would be my solution. Now, we could go to our graphing calculator and get exact solutions. The graphing calculator will do that for us, and we'll look at some other methods that we looked at in Algebra 1, and we'll continue to look at in Algebra 2 to find irrational roots, because that's what this is. This is an irrational root in this problem. Okay, and so let's look at our last example. I'm going to skip that second example there and go to example 5. And so this says this: the highest bridge in the United States is the Royal Gorge Bridge in Colorado. The deck is 1,053 feet above the river. Suppose a marble is dropped over the railing from a height of 3 feet above the bridge. How long will it take for the marble to reach the surface of the water? Now, there's a formula for this that we're going to use, and this assumes no air resistance, but our formula is here. H of t is equal to negative 16t squared plus h0. H naught is another way to say that, where t is time in seconds and h naught is the initial height above the water. Well, so the height of this marble, according to time, this negative 16 in front deals with gravity in feet per second. It's half of the gravitational constant, which is 32 feet per second squared. And that's on Earth, right? If we were on a different planet, on the moon or something, this number in front would change. And then h naught is our initial height. Well, the deck is 1,053, but we're holding it 3 feet over the railing, above the bridge deck, right? And so that will give us 1,056. And so when we go to solve this out, we're going to graph it, right? And so this would be one to graph on a calculator. So here's my graph. I've gone to Desmos and graphed this up. And so we see that our y-intercept is up here at 1,056. And you'll see that my y is in height in feet, my t is in time in seconds. So this is not how far the marble is going to be away from the bridge. This is how long it's taken this marble to hit this 0 mark, which the 0 mark in height would be the water. And so when does it hit? Well, it hits right here, and it looks like it hits really close to 8. Now, we could go to our graphing calculator and calculate the zeros and figure out what this exact point is. Or we could, of course, solve this by hand by plugging in 0 into here, which is what I'm going to do to get this answer really quickly. So I'm going to get the 16t squared is equal to 1,056. We'll divide by 16 to both sides. This is 66. And then we're going to take the square root of both sides, and so t is equal to the square root of 66. And so the square root of 64 would be 8, and so this is just above 8, and so there's going to be a plus and minus in front of this, and we'll talk more about that in a later section. So positive or negative, square root of 66 is going to be the square root of 66, and so t is equal to 8.12. And so our time is 8.12 seconds that we're going to hit the bottom of this gorge. All right, so this is section 3.2. I hope y'all have had a great day. The word of the day is miss you, because I do, and I will see y'all tomorrow when I'm back. Y'all have a great day.